Hello everyone. In this post, we would like to check the use of the dimensional formula in terms of the checking the correctness of a given equation. As we have discussed in the previous post, there is a principle called principle of homogeneity. According to principle of homogeneity, we can add physical quantities of similar nature, or we can subtract the physical quantities of only similar nature, so that we will be getting a similar physical quantity. That means when you write a physics equation, its dimensions along the left hand side shall be equal to the dimensions along the right hand side. Say for example, I want to write an equation, very popular equation that we know, like equation of motion, v square minus u square equal to 2as. Would like to check whether this equation is actually dimensionally correct or not. So I would like to write the dimensions of LHS. LHS is the subtraction of the two terms. Anyway, V is the velocity, rate of change of displacement. It's nothing but LT power minus 1 whole square. So the dimensions of the V square is L square T power minus 2. Similarly, U square is also a velocity. Velocity is rate of change of displacement whole square. So the total LHS dimension, the dimension of the LHS, the dimensional formula of the LHS otherwise is simply L square T power minus 2. Let us try to have a look at the RHS. Until now I have been only talking about LHS. Let us talk about RHS also. See, RHS is 2 into acceleration into displacement. 2 is a constant. Constants won't have dimensions and dimensional formulas. Only physical quantities will have dimensional formulas. 2 is not a physical quantity. I know acceleration is nothing but velocity by time, and displacement. Velocity can be further expressed as rate of change of displacement by time, and of course displacement. So LT power minus 2, displacement is again a length whose dimensions are again equal to L. So the dimensions of RHS is L square T power minus 2. It's very clear that the dimensions of LHS is equal to the dimensions of RHS. That implies we can say the above given equation v square minus u square equal to 2as is dimensionally correct. I am very clear, I am saying only dimensionally correct. We cannot prove whether it is scientifically correct, whether it is correct as per physics or not, basing on dimensional analysis. Why I am saying this? Say for example, if I have given an equation v square minus u square equal to 4as, this is also dimensionally correct, because 4 is anyway a number. It won't be having any dimensions because it's a constant. Therefore, it doesn't make a difference as per the dimensions whether you have written a 4, 8 or minus 3 or minus 4. So, every equation that is dimensionally correct need not be correct as per physics. But one thing is clear, every equation that is dimensionally wrong is definitely wrong with respect to physics also. Therefore, that's the conclusion that we need to know, that a dimensionally wrong equation is wrong even in terms of physics. But it need not be vice versa. A dimensionally correct equation did not be correct with respect to physics. That's one use of a dimensional analysis, that we can check the correctness, dimensional correctness of a physical equation using dimensional analysis. And the principle behind it is simply principle of homogeneity, which tells you that we can add or subtract only similar physical quantities, and the dimensions of LHS of a given equation shall be the dimensions of the RHS. Thank you.